All right, classwork 4.2. I forgot to start recording. I'm recording now. So let's say this is your equation. It's set equal to 0, but you can't just nicely factor this. Yes, quadratic formula. Do you remember the quadratic formula? Perhaps you learned it to a particular tune. A lot of people have learned through Pop Goes the Weasel. So if you remember it, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the quadratic equation has to have it set equal to 0 to work. So with the zero product property, either you can nicely factor after you have it set equal to 0, and then you can look at the individual factors set equal to 0. But you cannot do it for any other number. Or you set the equation equal to 0, and then you've got your A, B, and C for the quadratic formula. And so in this particular case, B is -2, so the opposite of -2 would be +2. When I square B, I'm squaring the entire -2. A is 1, C is -4, 1 times -4, and then 2 times A, where A is 1. And so this turns into 4 plus 16, which is 20. And you've got a number, but it can be simplified from there. So if you have to solve an equation that is quadratic, set it equal to 0. If it's not factorable, quadratic formula. And I'm going to simplify this a little bit. This is 2 plus or minus, and 20 is 4 times 5. So the square root of 4 gives me 2. 5 is stuck under the square root. And then I can distribute the division of 2 to get 1 plus or minus root 5. So that gives me my 2 possible answers in that situation. But I want to repeat, if I had started by looking at whatever number's on the right, I just make my factors equal to that number. That's incorrect. You cannot do this. And through the quadratic formula, we can see that the answers we would have gotten here are certainly not the correct answers. So when you're solving polynomial equations, number one, first thing, make sure one side of the equation is 0. And you're getting it equal to 0 through addition or subtraction if it isn't already set equal to 0. Then you're going to factor the polynomial like you did in the previous homework assignment, and then set each individual factor equal to 0. So let's do some examples. 1 and 2 have it set up nicely where it's already factored and set equal to 0. So as long as you see the equal 0, then once it is factored, each individual factor can be set equal to 0, and all of those are the answers. By the way, if you can solve these quickly, I am okay with you not writing the step that I just wrote. You can go straight to the answers once you see it factored. So this means that I get the answers of x is equal to 0. When I add 3 to both sides, I get a solution there. Over here, I have to first subtract 5 and then divide by 2. And I'm not going to be picky about how you write your answer because there are some technically mathematical ways to write this. And just so you're aware of that, it's basically to put a set notation around it. I do not expect you to do that. You can just list the answers and that's fine. Okay, number 2. There's a common error that people are going to make with number 2. If you look at all of the factors, that first red underline was just the 3. Will 3 ever be equal to 0? If you have just a number as one of the factors equal to 0, that doesn't give you any solutions. A very common error that I see is people will write 0 as a solution because they see something over there. But the only way that 0 is going to be a solution is if that what is multiplied in front is x, not a number. So notice this very important distinction, because I have now told you the 2 most common errors that I see when people are solving polynomial equations. If it's just a number there, not x, you do not get the solution of 0. Now, some of you already know the answer. I'm going to go through more detail for those of you who need to see it. Set each individual factor equal to 0. Subtract 4 to both sides, and you get an answer here. On this one, I want to point out to you that if you square a number and you get 0, that number that you squared has to be 0. You can also, if you're using some of the techniques we've talked about with solving, when you see a squared, you take a square root and you put a plus or minus sign on there. However, 0 doesn't have a positive or negative. If I say plus or minus 0, that's flat out 0. And I'm only getting one answer. And when I add the 1, I get 1. For a lot of you, though, you looked at it, you saw this factor and saw -4 makes it 0, and saw this and ignored the squared and just looked at 1 makes it 0, which is perfectly fine. You don't need to write this out. I pointed this out because I've had people who get confused on that, and I want to clarify before you get going. Yes. So if you set each one of these factors equal to 0, when you write 3 equals 0, it's a false statement. And you want to see the difference between that and when you set x equal to 0. This will only be true if the variable is actually 0.
Okay, so then for 3, what you just nothing really happens to it. It's just
Exactly. When it's just a number, you're not able to plug anything into a variable to create something other than, that's a 3. Yeah, absolutely. And this is why I'm pointing it out, because I've seen it be an error so many times. This is one of the misconceptions people have when they try to remember how to do it. The other thing is, don't worry about it if there's an exponent. You can just go straight into the x minus 1 equals 0, and that's going to be far easier. I just did this to show you that everything we've been doing so far is still in play. It's just, if you want to make your life easier, the only way that you can square a number and get 0 is if the number itself is 0. And so it's a little bit of a shortcut. And actually, I didn't clarify. The answers are -4 and 1. And yeah, so normally you're going to ignore this 3 when you're solving an equation. And if you did that automatically, it's either due to habit or you understand not to bother with it. And it made sense to you already. Let me make sure you're clear. You do not need to say this. In fact, I'm expecting for a lot of you that you're just going to write the answer and go on to your next problem. And I don't have an issue with that. If it's already in factored form, you can just list the answers. Now, these are examples of it's not already in factored form. The first one is already equal to 0, but when you look at number 4, it's not set equal to 0, so there's more that has to be done before you begin factoring. So once it's equal to 0, you should notice that you have x's in each term, and the smallest exponent on all of them is a 2. So all of them can be divided by an x squared. So when you factor that out, realize that you're dividing by x squared. So x to the 4th divided by x squared, 2x cubed divided by x squared, minus 15x squared divided by x squared. When you factor something out, look at what's left over. If it's linear meaning you've got like 2x plus 1, x minus 5, you don't have a 2 exponent. If it's linear, you're done. But this is quadratic, so you're not done, and you're going to keep factoring. You still want to have that x squared. And then as you factor, you're looking for two numbers that multiply to make -15 and add to make +2. And perhaps after a little bit of thinking, a +3 or a +5 and a -3. When you multiply them, you'll get the -15. When you add them, you will get the +2. Then throw x's in front and it's factored. So make sure, though, this is when there's just an understood 1 as that leading coefficient, that you can nicely do that. So now you have it, what it factored, so that you have first pulled out what you can, and then with what's left over, you have only linear factors. Now, you do not have to write down these 3 statements. You can go straight to the answer if this makes sense to you already. When x squared is equal to 0, you're only getting out x equals 0 for that. Subtract 5 to both sides, add 3 to both sides, and you get your 3 possible answers. And you can write them as individual, these x's are equal to, or a list 0, -5, 3. However you write your answer is fine. Okay, are you ready for number 4? First, make sure one side is equal to 0. And as I need to subtract 36x to both sides, notice that you have an x to the third power, an x squared, and this is just an x to the understood 1 power. You cannot combine those terms at all, so you just have 3 separate terms. 3x cubed plus 3x squared minus 36x is equal to 0. And now you're looking for, between these 3 terms, what can divide all 3 of them. You should notice that you have an x in each one of them. And the smallest exponent is the understood 1. And hopefully you also see that the numbers, the 3, the 3, and the 36, are all divisible by 3. So when you factor that out, you're dividing each term by it. 3x cubed divided by 3x. 3x squared divided by 3x. And then negative 36x divided by 3x. And you're not ready to go about solving until what's left over after pulling out the common factor is only linear. It's quadratic, so we've got another step. Since I just have an understood leading 1 here, I can more quickly look at 2 numbers that multiply to make -12, and when I add them, I get a positive 1. And then once you have factored, set each factor equal to 0, and if you can just write the answers straight up, you can feel free to do that. Subtracting 4 and adding 3. Oh. My dog is snoring. It's really funny. I was trying to see if he would snore into the microphone and be funny, but no. He only snores as soon as I take the microphone away, of course. Okay, any questions before I keep going? So that will get you started on solving equations when you have polynomials. Now, I want to make sure that you have correct vocabulary. If you don't have this printed out, you do not need to write everything that you see on this sheet. Just write down the things, excuse me, hold on. Just write down the things that the people who have printouts would need to be writing down. And I'm going to go over to the answers and just talk through the answers. So make sure you understand monomial. You should recognize that prefix mono meaning just one only. So it's one term versus a polynomial. And I'm going to come back to this, but I want to just make sure you see poly as a prefix means many. So a polynomial is a sum or addition and subtraction between several monomials. So a monomial is anything where you have a number times x to a power, but those powers can only be whole numbers, 0, 1, 2, 3, and so on. So this is a list of monomials, and I want to point out what isn't obvious. 5 is a monomial. It is the same thing as 5 times x to the 0 power. You don't need to be fully aware of that. You just need to know that any number is a monomial. But to emphasize the definition of monomial, the exponent is allowed to be 0. But when that exponent is 0, you're getting just the number that's multiplied in front. So a polynomial is adding or subtracting any number of these terms. And here are a few examples of polynomials. And what I'm going to do is focus on these polynomials to make sure to clarify vocabulary words. I've been using the word term. I want to make sure that you're very, very clear. When I use the word term, it's just stuff in between the addition, subtraction. In your homework, I'm going to ask you to list the terms of the polynomial. Know that I'm only having you do that to make sure you understand the meaning of the word term. So a comma in between the 2x and the 5. And make sure that you realize that when you see subtraction, that is actually part of the term, because really the terms are separated by addition. So what you have is 3x to the 5th is one term added to negative 9x to the 4th, added to 20x, added to 5x cubed. So make sure to not ignore the negatives in front. For the next one, x squared is a term. It is being added by a negative 5x and then being added by a negative 1. And if you have a monomial, that monomial is the only term. And the answers are posted if you need to look at them a little bit slower. Now, the constant term, that's the term that is not multiplied by an x. But you need to know that if there isn't a term that is just a number without being multiplied by x, then if you're asked what is the constant term is 0 if you don't see any. So again, that's constant term is the particular term that is just a number, no variable multiplied. I've been using the word coefficient a bit, but let's make sure you're clear. The coefficient is whatever number is multiplied to that x to the power. That actually includes the constant term. The constant term is considered a coefficient. So the coefficient of x in this first polynomial is 2. But loner 5 is also considered a coefficient, but we usually refer to it more as just the constant term. In the next polynomial, 3 is the coefficient of x to the 5th power. -9 is the coefficient of x to the 4th power, and that negative has to come with it when you talk about the coefficient. 20 is the coefficient of the x term, and 5 is the coefficient of the x cubed term. If you're asked for a coefficient and you don't see any number, it's understood to be multiplied by 1. And then again, -5, -1, these are the coefficients. Coefficients are -8, 9, and a -1. And then if you have loner 5, it's a coefficient as well as being called the constant term. The leading coefficient, that's super important. We're going to be talking about how important that leading coefficient is. So you need to make sure you understand when I say leading coefficient, it's only the number that is multiplied in front of the term that has the largest exponent. So the first thing you're searching for is the largest exponent. And let me talk about the second one. My exponents are 5, 4, 1, and 3. The largest exponent is 5. So the number that is multiplying to x to the 5th is my leading coefficient. For this polynomial that is linear, you have just a 2 as the leading coefficient. X to the 1 is the highest exponent. Here, the leading exponent is 1, the leading coefficient is 1, because that's the number that is understood to be multiplying in front of x to the highest power. Now be careful, because a polynomial doesn't have to be written in a certain order when it's presented to you. Look for the largest exponent. On this next one, 6 is the largest exponent. That makes -1 the leading coefficient. And again, there's always an understood 1 multiplied in front there if you don't see it. And if it's subtracting, that subtraction is part of that leading coefficient. The degree of a polynomial is simply its largest exponent. So when you see a line, that's considered degree 1, but know that it has to have its leading coefficient not be 0. So if you have just a constant, that is considered a 0-degree polynomial. That's really important that you understand. A constant alone is a 0-degree polynomial. But if you have a line formula, a linear, where you have a number times x plus a number, that is degree 1. Now, if your polynomial had been just the 2x and not having the plus 5, it would still be degree 1. For the next polynomial, the largest exponent is 5, so it's degree 5. And then you can see largest exponent is 2. And then here, again, be careful. It's not written in a particular order necessarily. 6 is the largest exponent. We're going to use the word degree a lot. Make sure you understand it means the largest exponent between all the terms. Then some vocabulary words you should be familiar with. You might already know them. Degree 0, we call that a constant polynomial. Degree 1, we call a linear polynomial. Degree 2, you're really familiar with quadratic. Degree 3 is called a cubic polynomial. Degree 4 is a quartic polynomial. And you're not going to be expected to know any further than that. But you can always look it up if you're curious. And again, these answers are posted if you need to, if I'm going too fast, because I'm also looking at the time. Okay. Actually, oh yeah, I had those pre-highlighted. Standard form of a polynomial. Just know that if the directions say to write the answer in standard form, know that you have to write it with the largest exponent first and then go down to a smaller and smaller and smaller exponent. So again, if you're told to write it in standard form. Now, don't let this freak you out. But for those of you who are planning on going further in math and really are interested in doing more with it, you do want to familiarize yourself with what this is saying. We use sub numbers to distinguish the coefficients of particular degree terms. So when we talk about the constant term, we can use sub 0 to talk about it. When we talk about the coefficient of x to the 1, we can talk about the coefficient a sub 1. But for those of you who are just trying to get through your math curriculum, just kind of the minimum requirements, you're not going to have to worry about this in this class. All right. Then I think that was, oh, no. Oh, yeah, we had examples. That's right. Some of you have probably went ahead and already got this done, and you're just sitting there waiting for time to be over. Okay, so basically, I don't want you to have to worry about too much with what I'm putting down here. And I just realized that that did not make it onto the next page, which is it was supposed to do. Oh, well. So by example, this is referring to all of these down here. So we want to know what is a polynomial and what is not a polynomial. And what I want you to do is, if it's a polynomial, just write the letter. If you look at a of x, it has two terms, and it's x squared, that's a polynomial term, minus 20, a constant is polynomial. Just write the letter a over here. No more needs to be said. Letter C. Letter C has a square root. You need to know that if you see a square root, it is not polynomial. The exponents have to be whole numbers. When you look at the square root of x, the exponent is fractional. The exponents must be whole numbers. Now, letter D. A polynomial is not a division of, this is actually showing a division of two polynomials. Even if I simplified this, I would distribute the division of the x, and this is sorry. This is actually a -1 exponent, and the exponent has to be a whole number, and a whole number starts at 0 and then goes 1, 2, 3, 4. And if you look at B, B is polynomial. And then as we continue looking, E is polynomial. F is meant to trick you, by the way. The variable has exponents 2 and 1. Those are whole numbers. The variable is not being square rooted. The coefficients are allowed to be any real number, including square roots. So F is actually a polynomial. The variable cannot be the exponent. And I realize my time is almost up. So I'm going to move over to the answers. And so it's a list of everything that is polynomial. And make sure that you take a look at what is not polynomial. You just have to know the difference between it's polynomial, it's not polynomial. And all we had left to look at not being polynomial was with letter G, the variable is not allowed to be in the exponent if it's polynomial. I, it has a fraction exponent. K, similar to G. X shouldn't show up in the exponent, and logarithms just don't. They aren't polynomial. Now, you're going to be doing in your homework something like this second example. So really, this is presented to you to make sure that you know how to do your first or one of your homework problems. So you're understanding what I'm asking you to do. The polynomials that we just had, a list of their terms is just putting a comma between them. The coefficients, the degree of that polynomial, the leading coefficient, the constant term, and it's written in standard form as long as its highest degree exponent first. And the standard form of polynomial b would be this right here. So today was just making sure to clarify vocabulary words on top of remembering how to solve equations. And you've done a lot of this before. The thing that's a step up is you're going to higher than degree 2. And your focus before has been on quadratics and lesser degree polynomials. So we'll focus more on higher than degree 2 polynomials. So enjoy your not sleeping in for sure this morning. Daylight savings time. Somebody end it.